The Planning Assessment Commission heard from many and varied voices last week in Gunnedah as they considered the future of the Shenhua project for the region. One of the different voices that we sort of haven't heard from very much in the conversation was from the Siding Spring Observatory. Not that close to the project, but they spoke with a lot of detail about the potential for mining and coal seam gas projects to impact on dust and lighting pollution in the region. I wanted to canvass that a little bit more, and I caught up with Peter Small, who's one of the technical operation officers at the Siding Spring Observatory, late last week to get a sense of what it was he wanted the Planning Assessment Commission to consider as it looked at reviewing the Shenhua project.
I work for the premier optical telescope site in Australia. That means that we are affected by everyone's light pollution no matter how far away they are. So even Sydney being over 400 k's away affects how we can do science here on the mountain. So the type of mines in the district around Gunnedah, they can have a negative effect on how we conduct our science, and even though they're only a distance between 100 to 150 k's, we are asking them to work with us by mitigating lighting problems, by not letting light spill upwards, using what we call full cutout lights so that they can reduce their effect on how we are doing our science.
Can you just tell us a little bit about the science that you're using with your equipment?
Oh, absolutely. So on the mountain itself, we host a lot of international and Australian astronomy type businesses here. So we've got the ANU itself has what's called the 2.3 metre telescope, which is the second largest optical telescope in Australia. And we also have what's called SkyMapper, which is the most technologically advanced telescope in Australia. Now, there is a lot of science. People are looking at why the universe began. We're also looking at exoplanets outside of our solar system. We are also using the SkyMapper maps the sky continuously over a 3-month period, and that information then becomes publicly available for other people to use that information and better discover things. One of the great things that they found only a short while ago was one of the oldest stars known ever to be discovered. At
the Planning Assessment Commission, Peter, you also spoke about the value of the dark skies in the area and what you're hoping to have the Warrumbungle sort of skyline included in.
Yes, so there is a International Dark Skies Association which we are trying to become a part of. There are only just over 20 in the entire world. There is none in Australia. We're trying to get the Warrumbungles recognised as an internationally dark sky, and which make it an asset of Australia, and it would be the first in Australia.
Wow. Well, what do you need to be recognised? How do you achieve that?
There's a lot of factors involved. It is a very thick manual. It isn't something you can just say, I'm one of them. You have to meet a very strict guidelines and have to be signed off. So part of that is to have very little light pollution. So in the Dubbo and Coonabarabran areas, we have worked very hard with councils there to mitigate light problems, and so a lot of the lights are all facing down. You don't have street lights facing up. They use certain globes. There is a lot of things involved, and that's why we also get involved with things that may seem outside our Shire district, but they still affect how we conduct our science.
This is an interesting situation you're trying to manage with the mines who have plans for the region. What kind of conversations have you had so far with Shenhua?
I think everything's been positive. Just not even Shenhua alone, but with Whitehaven and Idemitsu and the other large coal mining companies. They take on board what we talk about, and they do work towards using that. I mean, it's more efficient if light is facing down. It works out better for them and for us. So we discuss about lighting, and you would be amazed how much is actually in a light, even if it's LED or fluoro or anything like that, that what it can affect on what we do and what they do as well. So we're making suggestions about how they angle their lights, how they shroud their lights, where they face their lights, so on and so forth. And they seem very forthcoming. Everyone seems to be happy to talk to us, and we're happy to talk to them.
So what do you need Shenhua to do in particular? What have you asked the pack to recommend?
Basically, it is for dust monitoring, because dust actually, when it's flicked up into the air, it reflects the light and scatters it more, which then makes it seem a lot brighter and a lot more light than naturally would occur.
Oh,
and
right.
also we ask for the full cutout lights and for them to face lights downwards at an appropriate angle. It's not just light, it's dust has an effect too, yes, absolutely. But we believe that they will have dust programs such as trucks spraying the water on the roads to keep dust down for the locals and things like that. But that dust can scatter the light upwards, which can affect what we're seeing as well. Fred Watson, our astronomer on the site here, he has a saying that it's death by 1,000 cuts. So everyone might only think that, it's just one light and it's one light and it's one light. But when you group all those lights together, it really can damage what we're doing here. I mean, just what we can see in light pollution alone, the mirrors themselves are 1,000,000 times more sensitive than our eyes. So when you're trying to look at things, it's like shining a torch in someone's eye, and eventually all you see is just the torch. You never see what's behind it. And that's what we will lose here. We will lose the ability to see those faint and far-away objects just for something as simple as light and dust.
We're talking to Peter Small on ABC New England Northwest, and he's the Technical Support Officer with the Siding Spring Observatory and from the Australian National University as well. Peter, you were in the region the other week, though, as well, talking about the Santos plans for Narrabri, and all the time we're being asked to consider these projects in a cumulative situation. What impact could that project have on your equipment?
Obviously, they're a 24-hour type drilling mine. So they'll be using large drills which use a lot of lights. They're working 24 hours. So we would be asking them to the same sort of appropriate measures, keeping lights facing down, full cutout lighting, all the appropriate stuff. But the other problem that can occur is gas flares. So gas flares, we're asking them to only do that during the daytime and not overnight. Basically, it can affect the red shift of light. So we work very much in blue and red lighting, and that can affect what's going on. And also the type of VOCs that are emitted through gas mining itself, which is volatile organic compounds, because the gas isn't just methane, but it's made up of a lot of other products. If they were to blow into our district here, apart from the negative effect on humans, it has a corrosive ability to eat the mirror off the top of the telescope itself, so we would lose our reflectivity, and which would mean that we would have to re-illuminise more often than we do already.
Is that an expensive thing?
Yes, it's a 4-day shutdown at a minimum to get the mirror out, take it over, re-illuminise, bring it back, and that's 4 days lost of science that we would hope that we wouldn't need to do.
It seems, though, that you could get around the lighting and the dust issues if the companies agree to what you're suggesting. But the idea of that, the VOCs, how can you get around that?
We would like to think that, well, in America, there's certain states now that ask them to capture all gases, which means that there's no flare-offs at all. All gases are meant to be captured due to emission laws. And so in Australia, we don't have that protection currently. So we are asking that, we're hoping that they will capture rather than burn off. We would hope that technology would improve to limit what is being done, but at the moment where the technology's at, I can't see it being in favour of what we're doing here.
That's Peter Small there.